Okay, we've got ourselves a sequence this time. So a sequence A1, A2, A3, and so on is defined by A1 is 1, so that's the first one there, and then every other term after there for n is larger than or equal to 1, it's defined by this thing here. So k multiplied by an plus 1 all divided by an. So here we're just going to write down expressions for A2, A3 in terms of k, giving your answer in the simplest form. I'll just go ahead and write down A1 as 1 down here, just so I've got the sequence going. A2 then, I'm going to substitute A equals 1 into this formula here. So A2 is going to be k multiplied by A1 plus 1 all divided by A1. So all I've done is I've just swapped out the n there for a 1, and that gives me A2 because 1 plus 1 is 2. So A1 is 1, so I'm just going to substitute all the numbers in. I get 1 plus 1 in the brackets there, which is 2, and divide by 1, so actually I just get 2k. So that's quite nice. So our sequence so far is 1, then 2k. So let's go ahead and try and find A3 now. So I'm just going to substitute in yeah, can we still see it? A2 back into this formula at the top here and see what we get. So we have k multiplied by A2 plus 1 all divided by A2 here. Sorry, I'll just write that down here. So A3 is k times A2 plus 1 over A2. So that looks a bit like a 9, but it's an A. And A2 was 2k. So in there I've got k times 2k plus 1 all divided by 2k. Okay, so that k and that k can just kind of cancel each other out, and this is left with 2k plus 1 all over 2. So there's my sequence. Let's quickly write it down, just in case we need it, which we can see we're going to. We've got 1, 2k, and 2k plus 1 all over 2. So there's my sequence. Okay, so there's the first part of the question done. We have definitely got these in the simplest form. They can't go any simpler. You could turn this into a k plus a half, but it doesn't really help anything. So I'm going to leave it like that. Okay, so the next part then. So this was A. Let's go ahead and do part B. So given that the sum from R is 1 up to 3 of AR is 10, find an exact value for K. So remember to use the working out from the previous questions. There's no need to do the same working out twice. You won't get any extra marks for it, so just pay attention to it really. This just means, so actually I'll write down what this means. So R is 1 of AR is A1 plus A2 plus A3. Okay, so that's what it means, and it goes ahead and tells us that this equals 10, so I'm going to go ahead and write down that equals 10. And then I'm just going to substitute in these three values that we've just obtained. So I've now got 1 plus 2k plus 2k plus 1 all over 2, and that equals 10. Okay, and then let's fix everything up a little bit. I'm going to go through and times everything by 2 here just to get rid of all the fractions. So that's left and right side of the equal sign. So I've got 2 plus 4k plus 2k plus 1 equals 20. Let's tie that up a little bit. I've got 4k and 2k, which is 6k. And I've got 2 plus 1, which is 3. That equals 20. And go ahead and subtract 3 from both sides. I get 6k equals 17. Dividing through by 6, I get that k is 17 over 6. Okay. It does say exact value. Dividing by 6s is going to leave you with some nasty recurring decimals, and that's not exact. So I would leave it like that. I wouldn't really change it. I know your calculators can do it with mixed numbers and stuff, but just leave it like that. There's no need to do any extra work. you won't be rewarded for it. Yeah, there we go.